Good morning, everyone. Today I'm going to talk about the CPU that I have built, the 8-bit CPU. I built this in Logic Sim emulation, and it is a pretty basic CPU. The design is somewhere around from 1970s. So, but this the design is very important to learn or to know about because it was the start of computer programming and computer just like it was we just had the breakthrough of transistor to make such a computers in a small form factor. So let me tell you about the all the components. So all these four are the registers, 8-bit registers. These holds data until it is processed, and when the data is processed, it stays in the accumulator. The data is processed by the ALU. Here is the ALU. This ALU can perform logical and arithmetic both operations. So let's quickly talk about this ALU. So these eight are my first input. Oh, sorry. A0 is here and A1 to A7 are here. But it was just like I couldn't make it like A1 should be beside A0. So it works this way. And the second input is here. B0 to B7. So the first input and second is here. And this CN is carry N. If the last operation had a carry, so we can feed the carry again into the ALU. And S2 to S3 are my mode select. Like M is my mode select, and S0 to S3 mode select is to switch from logical to arithmetic operations. And S0 to S3 is to recognize which operation I want to do from the 16 operation that I have. Total, it can perform 32 operations. In total, it can perform 32 operations because 16 arithmetic and 16 logical operations it can perform. And the output comes out of here from F0 to F7. So these are all jumbled, but yeah, I have like from the wires I have unjumbled them and fed it directly to the accumulator. So next, these are few flags. If A equals to B, it will set to 1. Cout, if I have, if I have a carry, then the cout will give me a carry. These are just my, these registers, not registers, these are latches. These latches help me when I want to run the jump statements. Like if this this latch is active, then both of my inputs were equal. This latch will be active, and it will set this to 1. And if this wire is also 1, this wire is also having a current, then it will pass a current that we should jump, and it will generate a jump signal. And the counter, this is a counter, and counter will jump to that location. Okay, so I only have 2 jump statements. 3 jump statements in my CPU. If A equals to B, if the sign is negative, and unconditional jump statement. So next we have a counter. First, it is set to 0 0. Then when the first line is complete, this is the first line, C0 0 0 0 0 is the first line. It is having the data C0 and 1C. In total, every line is of 16-bit of data. 8-bit from this ROM, 8-bit from this ROM. Okay, so 0 0 line from both the ROM, we have 8-bit from this, 8-bit from this. So after the execution of this line, the data feed from this and these are the output of my ROMs. These are fed to my control unit. This is the control unit, and control unit make sure that the connections are right. Like if I am to add 2 numbers, so the which 2 registers should be added? The register 1, 2, 3. So register 0 to 0, register 3. which of the 4 registers we have as input 1 and input 2. So it makes the required connections, and the accumulator should connect to which ROM or register, or so the control unit makes the necessary connections to execute the proper instructions. After the CU, we have a RAM. This is the RAM is just for temporary data, as you know. But I'm using this. It includes in this we have VRAM and RAM included. So I have a small portion of RAM is reserved for the VRAM. So the changes I make to those locations will reflect on the display. Okay. So remember actually, but maybe 1, 2, 10. From here, I'm not able to select the use. From here, yeah. From here to here. This 1, 2, 3, 4, 5, 6, 7, 8. 8. So maybe it's from here 1, 2, 3, 4, 5, 6, 7, 9, 10. Maybe here to here is my RAM. VRAM. And the changes I make will be reflected on the display here. This is the display. This is my display. So I have a small program. Let me try to run it so that you will be able to understand what is going on. So I have to make a few changes for that to work. Let me just quickly do that. Okay. 04. So yeah, I wrote a program to let me just set my program counter to FF. So now my program counter is on the last line. So when it counts up, then it will jumps to 0, and then 1, then 2, then 3. So my program is maybe around 30 lines and a loop. So in total it will 50 lines maybe. But 50 lines execution is pretty fast. If I simulate in a good frequency, I was previously running it at 16 hertz, I will show you at 32 hertz so that it is fairly visible. You can see that it is running and how things are moving, and it will display the output. Yeah. I think I have made the necessary changes. So let's jump to the clock and start it. So I have started the clock. I have 2 clocks in my CPU. I have a primary clock and secondary clock. The architecture is like that. You can this is to properly execute the instructions. Like primary clock starts the instruction, secondary clock ends the instruction, and you can see the primary clock starts, then secondary clock starts, then secondary clocks end, then primary clock ends. So the secondary clock is for the before the primary clock jumps to its next tick, secondary clock already have ticked once. So that secondary clock checks the already instruction is being executed or not. If it's it makes sure the secondary clock makes sure that the instruction is already executed. Then we'll move to the next instruction. So it is for that. So let's go to main. So you can see the clock is started. It is running at 16 hertz. I have showed you that. Let's make sure. I've turned it to 32 hertz. And this this, and this is my start button. I'll start it, and it will. Oh yeah, I have to do one thing as well. One thing more. So in my program, the R0 takes the X value and R1 takes the Y value, and it on that XY value it prints a shape on the display. So let me just 0 3 let's say, and 0 4. Okay, 0 3 is my X value and 0 4 is my Y value. So 0 3, the the coordinate starts from left top corner of my display. So the X is along the right side and the Y is along the bottom side. Like 0 is here, 1 is here, 2 is here, like this. So 4, maybe it will display 0, 1, 2, 3, 4. I guess it starts from 1, I don't remember exactly. So 1, 2, 3, 4. Maybe it will print about here. So let's see. Let's start my CPU and notice that the program will run here. You will see the lines jumping from, and I cannot show you how data travels, but it's just wires. But you can see from here to here, between here to here, in some of these blocks, memory, the data will change because it has to display the shape there. So notice that, okay? From this to this. Okay, let's start the CPU. 3, 2, 1, go. Yeah, you can see the data changing. Data, like it is going to the next. Like, yeah, it displayed. It is still going because it is refreshing the pixels below. Now it has stopped. The FF, you can see the FF. FF is my halt command. It's called opcodes. FF is my halt F code, मतलब opcode. So now I can turn this off, and it has displayed on the 0 4, like 1 2 3 4. This pixel is my pivot pixel, so it follows there. So this in the middle is my will be on my XY coordinate, and this is my X coordinate. Okay, so let's see. I've told you that it will change from between here to here. So it is changed here and here. Okay, no other no other block is changed. No other data like storage element has changed. Only this one and this one. So okay, that's it. I've shown you the entire CPU, how it works, and the small program that I have made. Actually, I was building a whole Tetris game in this. So these were my input buttons. So I have not connected them yet. Not written opcodes as well for now. For any inputs, I cannot input while the program is running right now. But I will integrate them as well. So let's see in future. So next we will talk about each and every element and how the architecture and how the data is flowing, how it is processing, how it all talk about all the opcode. So thanks for watching. Thanks guys. Peace.